This is the Banana Data Podcast, a podcast hosted by Data IQ. I'm Triveni.
And I'm Will.
And we'll be taking you through the latest and greatest in data science, without taking ourselves too seriously. This week, Will and I cover the changing data viz landscape, the growing investment in AI globally, and the future of AI auditing.
There have been a bunch of acquisitions in the data science space recently. In particular, I'm sure maybe our listeners have heard about Salesforce and their big acquisition of Tableau. That was kind of two behemoths coming together. So in light of that, I actually found an interesting blog post that was talking about those acquisitions and how they play into the current state of data visualization.
That's interesting. We haven't talked about that a lot.
We have kind of ignored data viz, so I think maybe today could be its day. So briefly, this article touches on, the fact they make the claim that data visualization or standalone data visualization is dead. Super hyperbolic title, of course. But so by standalone data visualization, what the author means, or as I interpret it to be, it's data visualizations that are disconnected from organizational systems. So if you think about Salesforce, it's a system that helps organizations take actions related to your customer management and your sales process. And so the author's point is now by having Tableau so tightly integrated with Salesforce, we're kind of closing the loop. Those standalone data visualizations are dead. And instead, the author says, okay, visualizations made in Tableau now are not standalone. They're going to be somehow tightly integrated with Salesforce, and that's going to be better. So whether the claim is correct, if data viz is dead, I don't know. If these connected systems are valuable, I don't know. That's why I'm bringing it to you, Triveni.
Well, I fundamentally disagree with the premise here, right? Because I used to work in an organization where we did all of our charting in Tableau. It wasn't connected to Salesforce. It had nothing to do with Salesforce. And we still made decisions based on that data, based on those visualizations. We still impacted our clients' lives, right? And so to say that it's standalone, unless it's like integrated into some kind of system, I mean, it just feels over the top to say that. Not to ignore the fact that there are so many places where interesting data viz and research is actually affecting the way we think about policy, the way we think about, changes in our systems, all kinds of independent research that goes on, all kinds of different journalism. There's so much more to data viz than like, oh, it's integrated with a system where now I can take action on it.
Yeah, I mean, I'm sure the New York Times thinks that the data viz they're putting in the New York Times are influencing readers, even though they're not connected to some external organizational system, as I'm putting it. But I do think his point is reasonably well. If you think about data prep, which is something we've talked about before, having data prep close to data visualization is important, right? Because you know better than I do that to make attractive visualizations, it's still not trivial. And tools like Tableau help, but you still need to massage the data a little bit. And so the author doesn't talk too much about that. But in general, this idea of one connected system, it does, close the pipeline a little bit, make your life easier as an analyst. Don't you agree?
Oh, yeah, absolutely. I mean, if I can prep and clean my data and be, able to quickly visualize it and just confirm that the way I've done it all in one place is working, sure, that sounds great. But the idea that standalone visualizations, if you make a chart in Tableau, but it's not connected back to your Salesforce or it's not connected back to your other CRM or whatever it might be, those visualizations aren't as meaningful or impactful. That feels a little like over the top to say.
Yeah, I mean, one point that I agree with you on, and maybe disagree with the author on, is the way in which decisions get made. So by that, I mean, the whole point of data analysis and machine learning, as I see it, is to affect change in the real world, right? We're building these models or we're building visualizations so people change their minds, so people make decisions, so we have automated decision making. So this point of automated decision making is something that the author completely ignores in this piece, and one that I think, it's definitely relevant to you and I. So thinking about APIs, so application programmer interfaces, if you build a sophisticated machine learning model, you can just deploy an API and that can tightly integrate with whatever your external system may be. And there you're kind of cutting out the middleman and you're not even relying on data viz, which has risks, it has pros and has cons. But I thought that was something the author totally neglected here, this idea of like a completely short circuit loop where you go from data to model to action through the use of an API.
Right. So saying that the visualization itself doesn't add value into that system because you're letting sort of auto ML take over, which, as we know, can be problematic because these are things that we've talked about also in the past. So I don't think we should discount standalone data viz, nor should we say that it's like the end all be all, right? Like it is a tool in the data science toolkit. And whether you're an analyst or a data scientist or even a machine learning engineer, you're going to visualize things at some point. And to not acknowledge that importance is a fallacy. And it's a fallacy that we've made, right? Again, because we haven't even talked about data viz until now. And so I think that like this is something that oftentimes data viz gets sort of like put off to the end, right? It's like, oh yeah, and we'll make some charts.
Yeah, well, I think also one thing that people, including myself, should differentiate more on is the distinction between data viz to explore data and data viz to storytell. So I think you're kind of mentioning the end of a process is wrapping up that report through storytelling, so storytelling with data. And so I think both are important. And again, we need to maybe differentiate. Are we using a data viz tool to get a better understanding of our data quality and data relationships? Or are we using the data viz tool to make kind of a report that's going to go face outside in the world and ideally change minds?
Yeah, I know that when you go through like a data science course or like a machine learning course, whatever it is, they say, okay, before we start digging into the models, we're going to look at the data. We're going to try and understand our data. But, realistically, how much do we actually do that in our day-to-days? Maybe I'm guessing coming around a little bit to the author's point, maybe there's some value here because if we can integrate systems, we're able to step back and say, let me just first look at this data. Can I even take action on it without having to go and run it through some complex process that no one's going to understand? There might be value there. I'll give you that.
Yeah.
I do think standalone data viz has value, though, because so much of what we see now in cutting edge journalism, cutting edge like independent research is based around the storytelling element of good standalone visualizations, right? I mean, when I read some sort of New York Times report on XYZ, I don't really need to know that it's going to be integrated into some Salesforce system. I need to know, or I need to get some sort of information from that and be able to like be moved by that data.
Yeah, I think that's a good point. Also related to accessibility of data visualization. If we talk about integrated machine learning systems in an enterprise, that's not something that everyone has access to. And by that, I mean, not everyone has access to data impacting them in that way. Whereas if someone has access to the data, produces a data visualization, and then shares it with you as someone external to the organization, for example, the New York Times reader, they can still be impacted by the data in a way that if we were just relying on, integrated systems, they might not.
And I think even inside of an enterprise system, you can make data visualizations that don't have to integrate back, right? So like, okay, sure, maybe there's some company somewhere where they're using their Tableau Viz and it's driving how they use Salesforce in the next step. But maybe there's also really highly custom modeling that's happening. And as a result, we want to be able to see the output of that in some kind of visualization. And that visualization has to be made in a custom way, has to be made, standalone in Python or R. And that then provides more value to someone who needs to understand the inner workings of the model or what exactly is happening underneath all these layers, right? And so in some ways, custom data viz can help keep the human in the loop, right? And we're not automating everything and saying, don't worry about it.
This relates to our discussion last week about interpretability, right? And so visualization is one thing where no matter how sophisticated the machines, by the machines, I mean algorithms and models get, we're still going to have visualization as a way for us to remain in the loop or remain at least tangential to these intelligent AI systems.
Yeah. So I mean, I get what he's saying in terms of like integrating will improve sort of how you use data viz to drive decisions. But to say that like standalone data viz is dead is just like over the top. And I think a little bit intentionally ignoring the fact that there is real value to not getting rid of standalone viz. Well, speaking of acquisitions and, all the money being poured into growing the AI space, I want to talk a little bit about this report that came out earlier this year by the International Data Corporation. And in this report, they argue or they claim that we can expect the investment in AI, specifically in the Asia Pacific region, to reach $5.5 billion this year. And that's an 80% increase over 2018's investment. A lot of that, of course, is being driven by businesses in China and the retail industry.
Sounds like that AI winter is maybe not coming after all.
Right. So the argument here is that AI spending is expected to outpace the rest of the world in the Asia Pacific region, right? Specifically China, specifically in certain places. I think it raises a lot of concerns, not concerns, maybe thoughts, right? Around what do we do about AI that's being created abroad, but maybe used, in the US, or data that's being generated in a way where people don't have control over their data. How do we regulate that? Can we regulate that?
Yeah, I remember on a previous episode, we talked about ethical code versus ethical codes and regulation versus kind of implementation on the part of the coder. And I remember during that discussion being won over that we shouldn't focus on regulation. We should just think about individual coders, individual data scientists behaving well. But it does seem like if we think about cross-cultural, if we think about cross-borders, we do need some sort of standards in place that says, okay, when an idea is implemented in region X, how does it affect region Y? Or if a model is deployed in region X, how do we let that behave in region Y? And again, we've talked about GDPR a little bit in the past, but I think this is going a little bit beyond that.
Yeah, I mean, data privacy in China is a whole different topic, but I do think this idea of cross-cultural AI is important. If you think about, like, let's say maybe someone's investing into like some AI healthcare in China, where it's like the system will be able to predict when you need to go see a doctor because of XYZ factors. Mm-hmm. Well, the data they're using might not be cross-cultural. Mm-hmm. And as a result, you can make something that works really well in a specific community, but not elsewhere. And so this opportunity for bias kind of rises, I think, if we're not being more specific and careful with how we invest this money.
Yeah, I mean, we've talked about data quality a lot. This is, I think, one of those issues. And it also makes me think about the relation of what I'll call enterprise data science, which I think is kind of what this article is talking about. So big money being put into probably big corporations or very successful and promising Chinese and otherwise startups. There's a distinction between that and open source code. I think in the United States, it's definitely a fraught area and one that's still being figured out as we go. But I would say that we have so far done a decent job of making tech companies built upon and integrated with open source work. So therefore, the things that are being used in enterprise today, they're somewhat accessible to a broader audience. Because if you want to go in and look at the source code for XGBoost, that might be powering a huge model at Big Corp XYZ. You don't know exactly all the details of Big Corp XYZ's data, but at least you can go in, you can look at the open source code, and you can start to feel like you can audit their processes a little bit or better understand what they're doing. And this is a little bit to my ignorance, but I don't know the extent to which or not other countries and other regions are embracing the open source movement. And they may well be doing it much better than we are. I can't say.
Yeah, no, I mean, I'm not sure either. But you mentioned something about regulating tech within this country to, say like, all right, we want to make sure we can have open source or we can understand at least what people are doing. I actually think a little bit of the opposite is happening. I think some of the implications with like investing upwards of $5 billion into AI outside of the country kind of creates an opportunity for another little sort of mini Silicon Valley unicorns coming up. If you think about how these new startups, come to market and people just pour tons of cash into them without any sense of what are the implications of what you're going to do with this money or what your product actually is doing, or, in the case of some companies, how your CEO behaves and the company culture that you're cultivating. Mm-hmm. If we don't think about that as we're pouring this money into places, right, for AI, we're at risk of making a lot of the same mistakes again. And we're at risk of actually potentially making a lot of things that weren't so bad, pretty bad.
Yeah, and you do need to be careful, I think, when you're pouring money in. And by you, I mean venture capital, probably.
Definitely not me. I do not have $5 billion.
When you're pouring this money in, that throwing money at something, if it's good, it can help that good thing grow quickly. If it's bad, it can really exacerbate a bad problem quickly. And then thinking a little bit farther afield into the future, if we're pouring money and the consequences are bad or the results are not what we expected, kind of to some of our previous conversations, you might see some public backlash, you might see some disenchantment, and that, I think, would be sad, right? Because I think you and I both believe that there's good potential in the AI data science world. So again, responsibility is always a theme, and I think even responsibility in funding is something that everyone needs to be focused on.
Yeah, I mean, when you think about how money gets poured into tech and AI in the US, a lot of times these companies are taking money from venture capital or whatever it might be, and then they feel beholden to stakeholders. So as a result, they need to be showing value and be driving profit. So that changes their behavior. I do think that based on what I understand of how China and the Chinese government is investing in AI, I do think you get an opportunity for a little bit more robust AI systems that aren't geared towards delivering profit quarter after quarter. right? Because there is a lot of support from the government. There's a real interest in making China an AI superpower, as we've read and talked about previously. So, I mean, there's two sides to it, right? There's like this sort of, all this money's pouring in. We don't know how it's going to be used, what's going to happen. But at the same time, because of the way the system is structured there, we might get things that are a little bit more creative, a little bit more cutting edge than what we see now in Silicon Valley, where people are worried about bottom line.
Yeah, I think that's a great point. And to my previous question that I asked myself about open source, again, don't know everything, but I do know if you look at various benchmarks like the Squad question answering benchmark or ImageNet, these sorts of machine learning challenges, which we've critiqued their validity in the past. But for what they're worth, they're interesting benchmarks for people to measure algorithms, machine learning performance. And definitely in my time in the space, you started to see the top 5, top 10 performing teams. Increasingly, they're all universities from China or Asia. So to that point about where the funding is going, and is it going for, single-mindedly driving profit, or is it going for something a little bit more creative? The optimist in me is excited that maybe those $5 billion are going to be a little bit more nobly spent.
Now it's time for In English, Please, the part of the program where we break down complex data science topics in plain English. So today, Will, can you explain to me what Spark is in English, please?
Spark is a framework for running computations on really big data using distributed computation. And so when people say big data, typically what they mean by that is data that is hosted on multiple nodes or multiple servers. So that's what we're going to talk about today. When I say it's a framework for running computations on big data, I would imagine our audience will probably wonder, well, what is distributed computation? So distributed computation involves taking a single data set and distributing that or partitioning that over multiple servers, or again, sometimes referred to as nodes, and then running computations on that. So in the old world, in the simple single node world, doing things like finding averages were pretty trivial. So if you wanted to find an average for a particular column, for a particular data set, you would simply sum all the values in that column and divide by the number of rows in that column. I think we're all familiar with that. In the Spark world, or in the distributed compute world, what you need to do here is run that same process, the adding up and the dividing, but you need to run it across multiple servers. And then in a new final step, you need to collate those results into one single answer, which is the average of the column of your data set. And this, I think, is why Spark's predecessor was sometimes referred to as MapReduce. Namely, you were mapping a job to multiple servers, and then you were reducing those disparate answers from the multiple servers into one single answer. And so in terms of Spark and how it's improved upon MapReduce, I think there's some wonky details about things like better APIs and memory usage and resource managers, but I think we won't get into that right here and now. So just to reiterate, Spark is a really popular framework for running distributed computation on big data, and one that I see a lot with my clients, particularly used in conjunction with Kubernetes.
Thanks for explaining that in English. Now, Will, we've talked a lot about explainable AI and interpretable AI. And today I want to surface a sort of new line of thought that's coming into play, which is auditable AI, right? So AI needs to be audited. What do we mean by that, right? Sometimes we think about AI Netflix recommendations where, hey, you like Stranger Things, so you might like X. That kind of AI is pretty innocuous. It's not going to really harm us unless I really get recommended something terrible. So maybe auditing that system is not so critical. But in the case of, more high-stakes situations like lending, being able to understand why a model did something or how it did something can be done beyond sort of this interpretability, charting, all of these things we've talked about. In fact, there might be a case for third-party auditors, model auditors to come in and do this work.
I think that seems reasonable to me. I have some issues with it, but I can go into those now or later. You ready for them?
I'm ready.
I think auditing AI sounds great, but I think that we have kind of a fixed budget of attention and effort, culturally, societally, economically. And it seems to me like an audit, kind of by definition, is somewhat of a retrospective analysis, right?
Right, yeah.
And I feel like we should be doing more prospective analyses or warnings before we do the damage.
Yeah.
So if I deploy some really terrible AI model, it goes out, makes very biased, unfair, and problematic lending decisions. And then after the fact, we audit it and we realize that it was bad and it was bad for reasons X, Y, and Z. The audit's too late. So we need to get ahead of the game here. And I think, there are lessons to learn when you do retrospectives. And so that's obviously ideal to kind of have the forward-looking and backward-looking analyses on our AI projects. But I think an article like this, to me, I worry that it's distracting us from trying to catch things before they become too problematic. And it over-intellectualizes this problem.
Right. So your argument is that if we try to go for explainable or interpretable AI, that's more prospective, and auditable AI is more retrospective.
Yeah, and explainable, interpretable, and then also responsible. So, you would say, okay, we know why this is making the decision it's making, and also we have some built-in idea of the ethics behind this decision, and we're going to take action on it or not now.
So I think what I like about the idea of auditable AI is that it can be third party, right? So the explainability, the interpretability is something that theoretically you're breaking into your data process. But when you bring in a third party, a neutral party, someone who has no stake in the business, they're going to look at this data in a different way. Or even if you create a system that's willing to probe and interrogate the model on all the different possible values, that feels a little bit more, neutral to me than me, the data scientist, trying to prove that my model's not biased.
Yeah, I get that. I think also a risk here, and to your point about an independent third party, I mean, obviously people are aware of auditors for financial and tax-related activity. But in this case, another challenge of auditing, right, is you need to prove or somehow be credible as a third party or an unbiased third party, or irrelevant is probably the wrong word, but an irrelevant third party. And so with AI, everyone's so proud of both their data and their algorithms. So another complication here to me is you're going to have to find people who you're willing to allow into your Pandora's box and trust that they won't go and share those secrets.
Yeah. So definitely there's two ways you could think about this, right? Is you could either have these sort of citizen data science overseers, right? How there are review boards for police work. Maybe you have data science review boards that come out and they're the ones who are auditing these systems. Or you could have companies doing this, right? Companies who are vetted and who are well known in the space as auditors. I think, the article I'm referencing here, they make an argument that auditing models after the fact are actually more protective of the underlying algorithms, the underlying data, because these auditors are only looking at providing new, fictitious, or otherwise data points to a model and saying, okay, what are you returning to me? Is that what we expect? Is that harmful in some way? When I say that here are all these parameters of another row.
Okay, so kind of I think in other fields, maybe what people refer to as sensitivity analyses. So my understanding of a sensitivity analysis, right, is you say, given this distribution of inputs, what would be the various distribution of the outputs?
Right.
So that's a good point in that by doing essentially a sensitivity analysis on an AI model, you could not have to touch their data, but you could just see kind of hypothetically, if I make these assumptions about the inputs that you're getting, if my assumptions are right that your input population looks like this, then the output population is going to look like that. And that's problematic to me.
Yeah, no, I understand what you're saying. There is something interesting that I just came across recently. Kathy O'Neill, who's the author of Weapons of Math Destruction. She argues a lot against sort of these black box AI tools. She has actually started her own consulting firm for auditing AI. And right now, I believe it's in its sort of nascent stages, but it's a really interesting thought to me where it doesn't have to be maybe an overseeing board, some regulation, like the FDA of models, but instead we can create a space where businesses and consultants can come in and say, look, here are problems that I'm seeing with your data set, right? With your model, whatever it might be. I think there's room for that. I don't think we should throw out the concept of auditing just because it's retrospective.
Yeah, I think related to internal organizations and how they can self-monitor, I know somewhat of large organizations and how they leverage financial incentives to kind of essentially drive competition. So,
Right.
It's a big single company, but individual departments within that company are maybe selling to each other or buying from each other or somehow competing with each other. And they have their own budgets and financial incentives in place. I'm sure or wonder how you could do kind of a similar thing where you and I work for both company X, but it's your job to kind of optimize model performance, and it's my job to fight against you and kind of optimize fairness. And so again, we've talked about GANs and kind of algorithms competing, but thinking about incentive structures in organizations to do that, I think would also be rather useful.
Absolutely. Yeah, I'm excited now about this new focus on auditing. I think it's going to be another really good tool. And again, the toolkit of AI. It seems like a nice natural partner of explainability, interpretability. Now it's time for the banana data fact of the podcast. So bananas are grown in more than 150 countries, and it's actually widely believed that there are more than 1,000 types of bananas in the world, which themselves are subdivided into 50 different groups. But surprisingly, we really only eat one of those types commercially, which is the common Cavendish variety.
That's all we've got for today in the world of banana data. We'll be back with another podcast in 2 weeks, but in the meantime, subscribe to the Banana Data newsletter to read these articles and more like them. We've got links for all the articles we discussed today in the show notes. All right, well, it's been a pleasure, Triveni.
It's been great, Will. See you next time.